Hello and welcome to Nature's Numbers, the secret math behind beauty. I am Kenisha Muse, and today we will be discussing Fibonacci sequence, the golden ratio, fractals, isometries and symmetry, and examples in Filipino culture. First, let's start off with the Fibonacci sequence. The Fibonacci sequence starts with 0 and 1. Each subsequent number is the sum of the two preceding ones. Thus, 0, 1, 1, 2, 3, 5, 8, and so on. It's a simple yet powerful sequence found throughout nature. And here is the mathematical representation. Let's take a look at some real-life examples. In sunflowers, the number of spirals in the flower head follows the Fibonacci numbers, ensuring optimal seed arrangement. The arrangement of leaves on a stem and the pattern of flower petals also follow this sequence. The Fibonacci sequence is not just a numerical curiosity, but a pattern that nature employs for efficiency and beauty. If you look around you, you'll see the wonders of Fibonacci numbers in everyday life. Moving on to golden ratio. The golden ratio, approximately 1.618, occurs when a line is divided so that the whole length divided by the longer part is equal to the longer part divided by the shorter part. This ratio is denoted by the Greek letter pi. Here is the mathematical representation and a visual representation. Here are some examples of the golden ratio in real life. We have the Parthenon, the Vitruvian Man, and modern designs. While some debate its prevalence, the golden ratio remains a symbol of harmony and proportion in art and design. Next time you see a beautiful structure, think of the golden ratio. Now let's move on to fractals. Fractals are self-similar patterns, meaning they look similar regardless of the scale. The Mandelbrot set is a famous example of a mathematical fractal. So basically with the Mandelbrot set, it remains the same pattern no matter how far or how um, zoomed in you are. So some examples in nature and technology include coastlines, mountains, trees and clouds, digital art, computer graphics, and image compression. Fractals demonstrate the beauty of mathematics in nature and technology. If you look for these patterns in the world around you, you will see that they are everywhere. Next, we have isometries and symmetry. Isometries include translations, rotations, reflections, and glide reflections, sorry. So they maintain shape, proportions, and relationships, meaning that the object's size and shape remain unchanged after the transformation. So first we have translations. Translations move an object from one location to another without rotating it. So imagine a sliding piece of paper across a table without lifting or turning it. For an example, here we have a triangle. Imagine a triangle on a grid. If we translate the triangle 3 units to the right and 2 units up, every point of the triangle moves in the same direction and by the same distance. The shape and size of the triangle remain the same, only its position changes, as you can see in this example. And here is the mathematical notation. A translation can be described using a vector notation. For example, translating a point xy by a vector ab results in a new point x plus a and y plus b. Moving on to rotations. Rotations turn an object around a fixed point. So imagine a spinning wheel on its axle. So for an example, consider a square on a grid. If we rotate the square 90 degrees clockwise around its center, every point of the square moves along a circular path, centered at the rotation point. The shape and size of the square remain the same. Here is an example. And the mathematical notation, a rotation can be described using an angle and center of rotation. For example, rotating a point xy around the origin by an angle results in a new point. Moving on to reflections. Reflections flip an object across a line, creating a mirror image. Think of looking at your reflection in a mirror. So as for a visual example, here we have a reflection of a right triangle on one side of a vertical line, the y-axis. If we reflect the triangle across this vertical line, every point of the triangle moves to a position directly opposite of the line, of the line at an equal distance. The reflected triangle is a mirror image of the original. And as for the mathematical notation, a reflection across the y-axis changes the coordinates of a point xy to negative xy. Similarly, a reflection across the x-axis changes the coordinates to x, negative y. And lastly, for isometries, we have glide reflections. Glide reflections combine a reflection with a translation along the direction of the reflecting line. It's like walking in a straight line and looking at yourself in a series of mirrors. So here we have a visual example. Consider a rectangle on a grid. First, reflect the rectangle across a vertical line, the y-axis. Then, translate the reflected triangle horizontally by a certain distance along the direction of the reflecting line. And the mathematical notation can be represented by combining the transformation rules of a reflection and a translation. For example, a reflection across the y-axis followed by a translation of 3 units to the right can be described by applying both transformations sequentially. These isometries, translations, rotations, reflections, and glide reflections, are fundamental transformations that preserve the shape and size of objects while changing their positions or orientations. They play a crucial role in various fields, including art, design, and mathematics. An example of isometries in art are M.C. Escher's artwork and traditional mosaics. So M.C. Escher's artworks showcase isometries with complex symmetrical patterns, and traditional mosaics and tiling also utilize these transformations. And as for examples in technology and design, isometries are crucial in computer graphics, robotics, and architectural design, ensuring realistic and consistent spaces. Isometries reveal the elegance of geometric transformations in art and technology. Notice the symmetry in designs around you. So next, we have examples in Filipino culture. Mathematical patterns found in Filipino weaving. So weaving techniques like tinalak and inabel feature intricate geometric patterns, showcasing symmetry, repetition, and modularity. The weaving process involves complex calculations, ensuring consistent and harmonious patterns. So, traditional Filipino weaving demonstrates the interplay of math and culture and appreciating the patterns of these beautiful textiles. Next is with Filipino tattoos. So, you can often see mathematical patterns in the Kalinga tattoos, which are traditional Filipino tattoos. And you can also find these mathematical patterns in Filipino architecture, such as Bahay Kubo and Bahay na Bato. That is all for this presentation. I hope that you were able to learn something, and thank you so much.